In this video, we will practice evaluating inverse trig functions such as these. No calculators. Some background information that you need to know. I'm going to assume that you have long ago memorized the values on this chart. I will refer back to the chart from time to time, but the idea is you should have these key values just plain memorized. Now, what is an inverse trig function? One more time. Again, glancing at this chart, for example, we know that the sine of pi over 6 is 1/2. Alright, so let me just write that down again. We know that the sine of pi over 6 is equal to 1/2. Now, if I turned around and asked you this other question, and I said, what is the inverse sine of 1/2? Well, I am asking you for an angle. An inverse trig function is an angle. Let that soak in. An inverse trig function is an angle. What angle is it? It's the angle that if you took the sine of it, you would get 1/2 for an answer. Well, we just saw above that that is pi over 6. So the answer to this question would be pi over 6. Okay? An inverse trig function is an angle. What angle is it? It's the angle that you would have to take the sine of to get this answer. Inverse trig functions are also written another way. Instead of the little -1, sometimes you will see it written with the ARC in front, arcsine. So that just means exactly the same thing. It's still the same as inverse sine. I'm still asking for the angle. What angle, if you took the sine of it, would give you 1/2? The answer would still be pi over 6. Now, technically, you could take the sine of many other angles that would also give you pi over 6 for an answer, because you could go around the unit circle infinitely many times and land on the same spot. But you cannot have a function that's going to give you more than one answer. So what they came up with is they put restrictions on the range of inverse trig functions. So you need to memorize these restrictions. When you are talking about inverse trig functions, inverse sine or arcsine, you only can have answers between negative pi over 2 and positive pi over 2, including negative pi over 2 and positive pi over 2. In other words, quadrants 1 and quadrants 4. Alright, that way you get positive and negative values. And you're kind of you're staying near 0. For inverse cosine, it's only defined for the top half of the circle, from 0 to pi. Again, remembering that cosine is the x value on the unit circle. This gets you the negative values and the positive values. And one more time for inverse tangent or arctangent, the range is restricted to the right hand side of the circle, from negative pi over 2 to positive pi over 2. In this case, the endpoints themselves are left out, because you can't take the tangent of pi over 2 or negative pi over 2. Tangent is y over x. That would be 1 over 0. That would be undefined. So I can't say what angle will give you this answer, and it'll never turn out to be pi over 2 or negative pi over 2. So we leave those out. So just keep these in mind. If you're thinking of an answer that's outside of these restrictions, then you need to pick an answer that is within these restrictions. Alright, that should be enough background information. So looking at problem number 1, an inverse trig function is an angle. What angle has a tangent equal to 1? I'm not going to keep switching back to this chart over and over again, but you should have memorized that the tangent of pi over 4 is equal to 1. So the answer here is going to be pi over 4. Okay. And just briefly, notice that pi over 4 is within the restriction of the range. Looking at number 2, arc cosine. arc cosine is an angle. It's the angle whose cosine is equal to -1. So what angle has a cosine of -1? Well, this is not one of the ones on the chart. There's no -1 here for cosine. So it must be a quadrantal angle. So let's consider the unit circle for a moment. Okay, remembering that the cosine is the x value. So where will the x value equal -1? Well, that's going to happen right here at pi. So the answer is going to be pi. Alright, arc cosine is an angle. It's the angle whose cosine is -1. Well, guess what? Pi is the angle whose cosine is -1. Alright, because this is -1, 0, and you've got your x value right there. Is this within the range restriction? Yes, it is, just barely, but inverse cosine or arc cosine is defined over there. Alright, I'm going to start going faster and faster as I feel like you're getting the idea. Arc sine is an angle. It's the angle whose sine is -1. Sine is a y value. So where's the y value going to be? -1. The y value is going to be -1 down here at the bottom of the unit circle. Alright, because this is 0, -1. There's my y value. This is -pi/2. We are not allowed to call it 3π/2, even though that would be a coterminal angle. We have to stay within the range restriction. We have to stay on the right hand side of the circle. If I went around this way, I'm going into no man's land. We're not allowed to be over here. We can't go over there. We have to go this way, and that keeps us within the range restrictions. -pi/2, not 3π/2. Okay, so that was the answer. Arctangent is an angle. It's the angle whose tangent is 0. So what angle has a tangent of 0? Well, again, I'm looking for quadrantal angles and such. Okay, what angles have a tangent of 0? Remember that tangent is y/x. And I've got these points like 1, 0, 0, 1, -1, -1, 0, 0, -1. y/x, I want the answer to be 0. 0/1. Alright, this would be an answer right here. 0. Okay, the tangent of angle 0 is 0. So that's going to be the answer. Now there's another one over here. I'm just going to put an x here because this will not be the answer. But y/x, 0/-1 is also 0. Alright, I'm looking at pi. But the reason why pi is not the answer is because of range restrictions. Inverse tangent or arctangent, you can only have values on the right hand side of the circle. You can't get over here. Okay, that's why the answer is 0 and not pi. Okay. Inverse cosine. Inverse cosine is an angle. It's the angle whose cosine is 0. What angle has a cosine of 0? Well, unit circle. What angle has a cosine of 0? Cosine is an x value. Where is the x value going to be 0? The x value is going to be 0 on the y-axis. Okay, the x value is 0 in both of these places. But guess what? Only one of these is within the restricted range for inverse cosine. We can only be on the top half of the circle, so that's why we're going to pick this one and not this one. So that's why the answer is going to be pi/2, alright, because this is pi/2 up here, and not negative pi over 2 or 3 pi over 2. Okay, that is the only answer. Now, arcsine of radical 2 over 2. This is the same thing as arcsine of 1 over radical 2. These are the same thing. Arcsine is just an angle. It's the angle whose sine is radical 2 over 2. So what angle has a sine of 1 over radical 2? You should have memorized that that is pi over 4. The sine of pi over 4 is radical 2 over 2. The angle is the answer. Okay? The arc cosine of negative radical 3 over 2. Arc cosine is just an angle. It's the angle whose cosine is negative radical 3 over 2. Okay? Now, we have learned that the cosine of pi over 6, alright, I'm not sure where to write this. We've learned that the cosine of pi over 6 is positive radical 3 over 2. If this had been positive radical 3 over 2, pi over 6 would be the answer. But we don't want it to be positive radical 3 over 2. We want it to be negative radical 3 over 2. So pi over 6 is the reference angle. Alright, here is my unit circle with a bunch of pi over 6's showing. If pi over 6 is the reference angle, here are the 4 angles that have a reference angle of pi over 6. Alright, we're talking about cosine. Cosine is positive over here on the to the right because it's the x value. Cosine is negative over here to the left. Now we want it to be negative, so that means it's going to be one of these two. But we also have this restriction on the range of the inverse cosine. It can only be in the top half of the circle. So we want it to be negative, but we want it to be in the top of the circle. So that means it must be this one. Alright, that's the only one that we're allowed to do. It's only defined for these two, and we want the negative one. So what is this called? Well, these are pi over 6's. So this is 1, 2, 3, 4, 5 pi over 6. So that's why the answer to this one is 5 pi over 6. Alright, notice the answer is not just pi over 6, because that would be a positive radical 3 over 2. Notice it is not negative pi over 6 either. That would also be positive, and it would not be within the defined range. Okay, we had to go with this one. Anyway, I spent too long on number 7. Number 8. Arctangent is an angle. It's the angle whose tangent is negative radical 3. Now looking at our little chart, the tangent of what angle is positive radical 3? Pi over 3. So that tells me that the reference angle is going to be pi over 3. So I'm just going to put a pi over 3 over here. But that is the reference angle. Okay, the tangent of pi over 3 is positive radical 3, not negative radical 3. So we're going to have to make some modifications. Okay, so I like to look at my unit circle to help me think. Now that I know that my reference angle is pi over 3, it might help me to draw some pi over 3's. Okay, here are a bunch of pi over 3's. Alright, these are the 4 places that have a reference angle of pi over 3. All 4 of these are going to give me some type of radical 3 if I take the tangent. Tangent is positive here and here. We've memorized that. Tangent is negative here and here. We want a negative radical 3. So that means we're going to do one of these 2 angles. Okay, one of these negative guys. Now, the restrictions. Inverse tangent or arctangent, the range is restricted to the right-hand side of the circle. Okay, so how's that again? We want it to be negative and we want it to be on the right-hand side of the circle. Boom. This is the one that's negative and it fits the restriction. So this is the one that we want. Okay, what are we going to call this thing? The reference angle is pi over 3. This is negative pi over 3. Alright, that's the answer. That's the only answer. By the way, I cannot call this 1, 2, 3, 4, 5 pi over 3. I cannot call this 5 pi over 3 because going around the long way is going to take me into no man's land, the undefined part of the circle. We have to stay on the right hand side. So by going this way, negative pi over 3, I do not leave the defined range. Okay, number 9. Arctangent is an angle. It's the angle whose tangent is negative 1. So what angle has a tangent of negative 1? Now this is, ignoring the negative sign, this is on our chart. We've memorized that the tangent of pi over 4 is positive 1. Not negative 1, but positive 1. But that's enough to tell us the reference angle. So the reference angle must be pi over 4. Okay, because we're just off by a negative sign. So let's consult the unit circle to help us think. Alright, if the reference angle is pi over 4, guess what? I'm going to draw some pi over 4s, y'all. Alright, these are pi over 4s. You can tell because I've split the top half of the circle, pi, into 1, 2, 3, 4 pieces. So these are the 4 places that have a reference angle of pi over 4. Tangent is positive in the first and the third quadrant. Tangent is negative in the second and in the fourth quadrant. We want it to be negative, so right away that narrows it down to one of these two. So now it's just a matter of where's tangent defined, where's inverse tangent defined. The range has to be on the right hand side of the circle. Alright, so let me get this straight. It has to be on the right hand side of the circle and it has to be negative. Boom! It's got to be that one. What are we going to call it? We have to call it negative pi over 4. We have to call it that. We cannot call it 7 pi over 4. Okay, you can't go the long way around. That takes us into the undefined range. Okay, number 10. Arcsine of negative radical 3 over 2. Arcsine is just an angle. It's the angle whose sine is negative radical 3 over 2. So, what angle has a sine of negative radical 3 over 2? Well, ignoring the negative for a second, this is one of the things that we should have memorized. Okay, the sine of pi over 3 is radical 3 over 2. Not negative radical 3 over 2, but positive radical 3 over 2. Alright, that means we have found the reference angle at least. Alright, so the reference angle is pi over 3 because the sine of pi over 3 is positive radical 3 over 2. Now that we know the reference angle, we can figure this out. Okay, we're talking pi over 3's. This is what pi over 3's look like. Alright, each one of these is pi over 3. Alright, these are the 4 places that have a reference angle of pi over 3. We're talking about sine. We're talking about y values. So these two up here are positive. These two down here are negative. We want an answer that is negative. So we want one of these two at the bottom. So which one is it going to be? Well, look at the restrictions. The inverse sine function can only have answers on the right hand side of the circle. Okay, so we want it to be negative and it has to stay on the right hand side of the circle. Boom! It's got to be that one. What are we going to call it? We're going to call it negative pi over 3. That's the answer. Okay, have to stay within the defined area. Number 11. Arcsine is just an angle. It's the angle whose sine is 0. So the sine of what angle is 0? This is not on the chart. I said chart. This is not on the chart. We need to look at quadrantal angles when we're dealing with this. So let's glance at the unit circle. What angle has a sine of 0? Remembering that on the unit circle, sine is y values. So these are the two places where the y values are 0. These are the two places where the sine is 0. Which one of them is in the restricted range? Well, hopefully now you've memorized that for the sine function, it's the right-hand side of the circle only. Remember, the inverse sine function has to be on the right-hand side. Okay, that means it's got to be this one, which is angle 0. Alright, so the sine of angle 0 is a value of 0. Okay, so to be clear, this is angle 0, not answer 0. Anyway, moving on. Arctangent of 1. Hey, arctangent is just an angle. It's the angle whose tangent is 1. So the tangent of what angle is 1? Well, that's right off the chart. Right off the chart. Tangent of pi over 4 is 1. So the answer is pi over 4, and that's in the range restriction, so we don't have to think about it any further than that. Inverse cosine of 1/2. Inverse cosine is just an angle. So the cosine of what angle is 1/2? Well, that's going to be pi over 3. Alright, that's off the chart that we should have memorized. The cosine of pi over 3 is 1/2. So pi over 3 is the angle that we were looking for. And pi over 3 is within the range restriction for inverse cosine. So that's the answer, and we just simply move on. Alright, what is the inverse sine of negative radical 2 over 2? Hey guys, inverse sine is just an angle. It's the angle whose sine is negative radical 2 over 2. So, the sine of what angle is negative radical 2 over 2? Well, ignoring the negative sign, I know that the answer is going to involve pi over 4. Alright, what I have discovered so far is the reference angle though. Alright, the real answer may or may not have pi over 4 in it. So this is one of the things we've memorized. Alright, the sine of pi over 4 is 1 over radical 2, or radical 2 over 2. So that's where I'm getting the pi over 4 from. But that would be positive radical 2 over 2. We need negative. So if I want to get negative, I think it's a good idea to look at the unit circle to be safe. So if I know that the reference angle is pi over 4, I'm just going to quickly sketch some pi over 4s. Alright, these are each pi over 4. So these are the 4 angles that have a reference angle of pi over 4. Alright, each of these are pi over 4. Sine is a y value, so sine is positive up high above the x-axis and negative below the x-axis because it's a y value. We want it to be negative. That means it's got to be one of these two on the bottom, but the sine function, well, the inverse sine function, the range can only be on the right hand side of the circle. So that means, boom, that's the one that must be the answer. Alright, has to be on the right hand side. Okay, so we shall call that negative pi over 4. The reference angle is pi over 4. This one is negative pi over 4. Okay, don't think that you can always just take the reference angle and stick a negative sign in front of it. That works pretty often, but every once in a while that's not the case. We saw one of those earlier. I don't remember. I don't feel like hunting for it, but you can't always just, oh, it's negative, I'll just take the reference angle and stick a negative on it. That, as a rule, does not always work. Okay, now the remaining problems involve this a function inside of a function. So we're just going to do this in 2 steps. We'll do the inner part and then we'll evaluate the outer part. So looking at the inverse sine of 1/2. Inverse sine is an angle. It's the angle whose sine is 1/2. So what angle has a sine of 1/2? Well, that's pi over 6. So this is pi over 6. Okay, that means looking at the outer function, all right, looking at this, we have the sine now of pi over 6. Now, so what is the sine of pi over 6? Well, that is 1/2. Now, I know what you're thinking. You're doing it the long way, Burton. If you have the sine and its inverse, those are just going to cancel out, and you're just going to get this for the answer. Well, again, that's going to work a lot of the time, but not all of the time. So it's best just to evaluate the inner part and then evaluate again. Don't think you can always just cancel them out, because that works often, but it doesn't work every time. Let's look at this one. 4 pi over inverse sine of the sine of 4 pi over 3. Okay, the sine of 4 pi over 3. What's that? Well, I know that the sine of pi over 3 is radical 3 over 2. Alright, what about 4 pi over 3 though? So in the back of my mind, here's what I'm thinking. I know that pi over 3's look like this. Okay, so 1, 2, 3, 4 pi over 3 would be right here. Sine is a y value. Y values are negative down here. So this would actually be negative radical 3 over 2. Alright, not positive radical 3 over 2. So I have just evaluated the inside part. Now I've got to do the inverse sine of negative radical 3 over 2. Now it would be tempting to say 4 pi over 3 because we already have that angle marked, and we already know that that's going to give you negative radical 3 over 2 for the answer. But only problem with that is this point out here, ladies and gentlemen, is not within the value, the range restriction for the inverse sine function. Okay, it is outside. It has to be on the right hand side of the circle, and this is on the left side of the circle. So we cannot say 4 pi over 3. Instead, we got to find something else. Well, check it out. These, looking at the unit circle, all 4 of these angles have a reference angle of pi over 3. Okay, they are all going to give us some kind of radical 3 over 2. But it's just that these two are going to be positive because sine is a y value, and these two are going to be negative because they're down low. We want it to be negative, so it has to be one of these two, but the inverse sine function can only give you values on the right hand side. So that means it has to be this one. Alright, this one over here was not in the range restriction. This one is. So that's one we're going to use. And we are going to call that one negative pi over 3. So the answer here will be negative pi over 3. Okay, see, notice you cannot just cancel out the sine, the inverse sine and the sine, and put the what's left. In this case, it turned out to be something different because this is not in the defined area. Okay, I think we're going to have something similar here. Yeah, because 3 pi over 2, remember, just a quick sketch of my unit circle, 3 pi over 2 is down here at the bottom of the unit circle. This is outside of the range restriction for cosine. You can't be down here. So beware. You cannot just cancel these out and say, oh, 3 pi over 2 must be the answer. That's not within the defined range for inverse cosine. So we need something else. So let's just evaluate this though. So the cosine of 3 pi over 2, again 3 pi over 2 is right here. This is 0, comma, -1. The cosine is the x value, so that's 0. So that means this right here, the inside part is 0. So that means what I have is the inverse cosine of 0. So now let's talk about that. Okay, inverse cosine is just an angle. It's the angle whose cosine is 0. Okay, so the cosine of what angle is going to be 0? Well, there are two of them, remembering that cosine is an x value. Alright, x is 0 here and here on the y-axis. We already discussed that this one's going to be a no, because it's not in the range that is defined for inverse cosine. But this one up on the top, yeah, that one's cool. So this is the one that we have to use. So we're looking for an angle. Inverse cosine is an angle. What angle is this? It's pi over 2. So the answer is pi over 2. Okay, I think we are at the very last one. Okay, again, I cannot just cancel these out and put negative pi over 6. Because negative pi over 6, alright, negative pi over 6 is like right here. Okay, there's negative pi over 6. And that angle is not in the defined range for inverse cosine. Alright, so instead I have to think a little bit more. What is the cosine of negative pi over 6, first of all? Well, we have memorized that the cosine of pi over 6 is radical 3 over 2. Alright, what about the cosine of negative pi over 6 down here? Well, cosine is an x value. So both of these angles have a reference angle of pi over 6. And guess what? Both of these have a positive cosine, because cosine is positive on the right hand side of the circle. So the cosine of negative pi over 6 is still positive radical 3 over 2, because it's on the right hand side of the circle. We're talking x values. So now we're going to do the inverse cosine of positive radical 3 over 2. Inverse cosine is an angle. It's the angle whose cosine is radical 3 over 2. Cosine of what angle is radical 3 over 2? We just spoke about that. It is pi over 6. The cosine of pi over 6 we have memorized is positive radical 3 over 2. So pi over 6 is the answer for number 18. Alright, that video was a little bit long, but I just wanted to power through and get it done. I hope it was helpful. I hope you understand. I look forward to helping you on the next video.